All right, for this section in 5-7, what we figured out so far is that this whole section covers all of our 5 triangle congruences and then throws in this corresponding parts of congruent figures are congruent idea. And so what the bottom line is here, what we want to get at is if we can prove any triangles are congruent by our AAS or our SSS or ASA or SAS or our HL, if we can prove triangle congruence using any of these and we can knock that out first, as soon as we can say 2 triangles are congruent, like the idea here, if we prove 2 triangles were congruent by SSS, if we prove that, then second, our corresponding parts of congruent figures would tell us that all the angles are congruent. So like if we had an AAS proof, once we knew that the triangles were congruent by AAS, we would know that the third pair of angles and the 2 other pair of sides are congruent. So explain how to prove. The first thing that this is going to be second. Second, by C, corresponding parts of congruent figures are congruent. If I can prove those 2 triangles are congruent, the second thing I can do is say, all right, those pieces are also congruent, because those aren't marked on the drawing. When I looked at this one, as soon as I started looking at this one, and this is so similar to things we've done before, I'm just matching up parts that are marked congruent. At B and C, I got a pair of angles. When I look at this, use colors to code. At A over here and E, I've got another pair of angles. And then I have the non-included side, that AB and DC. Those guys are marked congruent. And so for a proof, the first thing that I would do is show congruence using this. Show this congruence. And this congruence, I mean the AAS. And I have all the parts highlighted. You know, like if I had to go into a proof, I would just be busting those parts apart. And then once I've got this, that's going to tell me then, since these are congruent, I could go in and make marks on side EB and side AC, and they'd be congruent to each other. That's the big idea through this whole assignment. I'm going to move a little quicker now. So I want to get at angles A and angle D. That's going to be my second step. By corresponding parts of congruent figures are congruent. Before I can get to that step, I've got to prove these 2 triangles are congruent. I'm going to use, I think, SAS on this one. AC and DC are marked congruent to each other. There's a pair of sides. I got the angles up here at C. These 2 different angles are marked congruent. There's a pair of angles. And then if I throw in transitive property, that BC is BC, there's my pair of sides. So just by color coding, I'm saying this can be proved this way. So the first thing that I'm going to do is show this congruence, and it's all mapped out by color. And since it's all mapped out by color, after I've done that, I pull in that corresponding parts of congruent figures are congruent, and I could mark these angles congruent as well. So it's just match up, prove somehow, then you can make the assumption about the others. Now number 3, I'm going to hit number 3. I'm going to do 4 first. I'm going to move down here to 4. This one's a little more cut and dry. The second thing that I want to do is be able to say that H and J, and hopefully I can do that by corresponding parts of congruent figures are congruent. And when I look at this one, I see right away I can use a side, side, side. And so then in my plan, or what I'm showing here, is that HI and IJ are congruent. There's a pair of sides. I can say HK and KJ are congruent. There's another pair of sides. IK is IK. That would pull a little reflexive in. There's another pair of sides. And so I say, first, I'm going to show this congruence. And so I'm just setting myself up for statements and reasons. We didn't have to do that. We just had to show what we were going to do. And whenever we're tackling a proof, we've been color coding as well. So it's not like anything that's that out of the ordinary. I hope I'm making it just seem a little more simple. Prove they're congruent, then you can assume the parts by that CPCFC. Now, number 3 is a little bit trickier because of the parallel line markings that we have. And the parallel line markings that we have, watch this one through and through, because if you wait to jump into this after I start coloring it, it's going to be really confusing to figure out. So you guys see that PR this side PR and SQ, they're marked parallel to each other. They're not marked congruent. And so in the end, we want to be able to say these two triangles are congruent, and then we can pull in that corresponding parts of congruent figures are congruent. That would happen second. But my first thing is going to be, can I figure out what congruence formula or what congruence theorem I could use from the choices? And with this one, you guys, the parallel, well, let me do this. I think we've got angle, side, I gotta remember, I can't remember. I'll have to come back and color code it. The first thing that I want you to do is take a look at the parallel lines PQ, and you may not wanna, you might wanna just do like a dash line or something to extend that. Do you guys see how these two lines are parallel by the markings? And I know they're congruent. We're gonna come back to it. I'm just using the parallel idea right now. And if I think about this PS coming through as the transversal, two angles cut by a transversal, or I'm sorry, two parallel lines cut by a transversal, this lets me go and say right here, at angle P, it's QPS. That's alternate interior to this one. And with two parallel lines cut by a transversal, we know that alternate interior angles are congruent to each other. So actually, I'm comfortable. I colored those orange. That's my, and I'm just putting here. I'm okay with putting this up here now. I see how it's going to play out. I see how it's going to play out because right now that I'm between this, I'm going to grab another color, you guys. Notice your reflexive right here. There's my sides. There's my sides. That PS is PS. Now I'm going to take this drawing and look at it a different way. And this is where I'm like, you got to pay attention. I'm going to hold off. I still see a bunch of pencils coming up and down on that one. Now, I'm going to ask you to pay close attention to the second pair of parallel lines. That's going to be these two. You see how PR and QR have the double birdies on them to say they're parallel? Boy, this is tough if you're not working with me. Now, that moves alternate interior angles to here. That transversal is still this. But that gives me alternate interior angles here because those lines are parallel. And so those guys are brown.
So is it double lines?
I put double marks on those because these two are congruent to each other and then these two are congruent to each other. So this one is an angle side angle. You got to show this congruence. This one was tricky. Yeah, there's oh, you could have done an SAS on that one. Yep, you guys, if you had an SAS on that one, that worked. Then you only had one because you had these sides. You could have done an SAS on that one. I pulled in both pairs of alternate interior angles, but if you had SAS, for sure that would work. And that means then that you brought in this side. So you would have had like my green, and then I would have had to use one of those pairs of alternate interior angles and then bring in that PQ is congruent to RS because it was given to us. Yeah, SAS will work too. Yeah. Right, like, write a plan to prove. You know, so like it's just when we tackle givens and we start color coding, that's kind of where we're at with it. You know, we just don't have to go into the two column statements reasons. You'd have to pull reflexive in there, yep. These would, the way I talked about it, you'd have to do definition of alternate interior angles because of the parallel lines. Make a little more sense? Yeah. That's what we have to do in the end. You can't bring that into your proof. If you had SAS, you better have PQ is congruent to RS. All right. Now, I'm going to go on to number 5, you guys. This number 5 problem actually is so real life, it's not even funny. Like, they want us to figure out what the distance across the pond is, and the idea is to do it indirectly. What side corresponds to MN on this other triangle? So, here's the thing. If we could take a measurement of this on land, it would be as wide as the pond. If we can take a measurement of that on land, it'd be as wide as the pond. Now, it's when I glanced at this, you guys, I'm in my same boat. Like, I want to get to, if I can measure this, corresponding parts of congruent figures, that'll tell me that. So what proof can I use, or what triangle congruence can I use to prove these two triangles are the same and then justify, yeah, if these two triangles are the same, for sure MN and JL are the same length. And what I noticed right off the bat, I think this is an angle side angle. Those right angles at M and E, there's a pair of angles. I got that MKKL congruent marked. There's a pair of sides. And what kind of angles do I have here that I'm marking? We always got to look for these. What are they? Yeah. Oh, I did it again. There's my ASA. So like Nai was asking, you know, so if you had to do a proof, this was given. They were marked. They were 90 degrees. This was given. They were marked. This one would be justified by vertical angles, the definition of vertical angles. So if you had to write a proof, you had to go write the proof, that's what you would do. So my first thing is, and it says, prove that your method works. So actually in this one, let's beef that up because I'm not writing this as a formal proof. I'm just going to explain better. Prove that your method works. So in my explanation, and you got to write this out because if you're not writing an actual proof, we need to have a good explanation for this. First, we'd show that the two triangles are congruent. We'd show that the triangles are congruent by ASA. And I'm going to say C, color coding, because that's all right here. Prove they're congruent by ASA. Take a look at my color coding up there. Then, by corresponding parts of congruent figures are congruent, we know that MN segment, that's across the pond, is congruent to JL. So if we measure JL, we'll know how wide the pond is.
So you just explain what we just did, right?
You got it. Yeah, so that one, and you guys, this is real life. Like, this is how you can't run a, I mean, think about it. Can I roll a tape measure across a pond? Not if it's not frozen. You know, so I'm not going to just wait till the pond freezes to do it. If I can measure, if I have a reflection of what that length is coming over here, you guys think about it, it's kind of a rotation and a reflection. I can measure out here and make that assumption. Now, moving, I'm going to wait. I still see some pencils moving. Have your 5/8 out. I'm going to go right into that 5/8 and explain number 9 with you guys on this same video. No, I'm not going to explain it on this video. I'll make another one. Now, last but not least, I want to get down here to DE. The thing that I want you guys to do is make sure you have enough evidence here. I found in first hour a lot of people were just like, yeah, DE's 5, and there was nothing to show for it. First thing I want you guys to do, take a look at this triangle on the left by itself, ABC. Find out what this missing angle C is. Take what you're given away from 180. 180 minus 84 minus 52. What's angle C, you guys?
44.
You guys, so everybody did that. You did the math and you found 44. Show the math over here real quick for me. Put your evidence. Did you get your angle E over here by taking those things away? What's angle E? Make sure that you're showing the measurements of those. So the measure of angle E is, anybody get that one? That one's 84. Show it, okay? It says explain your reasoning. You need to have you need some stuff that explains your train of thought there. Now, this could not be, like, I know all the angles are equal, that's great, but I don't have an AAA triangle congruence. So actually, you guys notice how AC and DF are both 7? That's going to be, between these, you guys, that's a pair of sides that are congruent. And then I want you to recognize here, I got an angle, I got an ASA going on. Explaining your reasoning is just not putting a yes or no on these. It's using the ideas that these congruence theorems have introduced to us. So by ASA, oh, I did it again. I really hope that didn't show up in my video, but dang, was that funny. This is ASA. Oh my God, Finley, that is way too funny. Okay, so by ASA, you guys, how long? So now here's my triangle congruence thing. If I know these two triangles are congruent, if AB is 5, how long is DE? That's what they wanted, and there's my thoughts on how.